Okay, so today we're going to graph polar equations, and you've already looked at page 547 and 548, and today we're also going to focus on sketching the graphs of these. So you guys are right, it is a circle. The radius will be n for that example 1, and then I wanted you to know that the graph is going to consist of all of the points that have a radius of n, and then that's what's going to create the circle. So when you think of all the points that have a certain radius, okay, it would be like you have all these points together that have the same radius, and then if you connect all the points together, they're going to end up making a circle. It's a pretty good freehand circle. I'm just saying, doesn't always happen that way. All right, and then I asked you to graph the equation from example 1 on your calculator, and I did mean example 1 from your textbook. We will graph example 1 together as well. So the first thing you have to do is find the mode. Okay, so if you go to mode, it's right here next to the second button, and usually what you have highlighted is this function. So we're going to go over to POL, which stands for polar. Do you guys see how that's the 1, 2, third one? Okay, that's when we start graphing with this. See how the 1, 2, 3, what's the third variable on this button where we usually use x? Theta. So this one is going to be in terms of theta. Okay, so I'm going to go to y equals to graph, but I don't have y equals anymore. What do I have? I have r. We're going to talk about that relationship as well. So if you graph r equals 3, if you look at your window, you guys should naturally have 0 to 2 pi. The step there, I usually set it at pi over 12, but you can just keep it at its natural one. When you're graphing this, did you guys get something that looks more like an oval? Yeah. I changed my window the last hour. I'm going to change it back. Do you guys have negative 10 to 10?
No.
Yeah. Okay, so, but if you change your window from something else, that's the only reason why it wouldn't be. So like my x and my y are different.
It's from the book.
It's from, your example 1. So r equals 3 is what we're graphing. So if we're graphing r equals 3, it does kind of look like an oval. Can anybody tell me how we know by looking at it, though, it is a circle?
Because it has 3 on each side.
Yeah, Ethan?
Because if you look at the tick marks, they both have the edges of the edges.
Yeah, they go out to what? Yeah, they're going to be the same, right? So 3 here, 3 up, 3 to the side, and then 3 down. So your radius is going to be 3. If you don't like the way that looks as an oval, you can go into zoom and then see where your number 5 says z squared. And then it gives you a better looking circle. It's just a fuzzy circle is what I say because the ends look a little fuzzy. Okay. All right. So we are going to sketch a graph of the polar equation. Oh, yeah. Yep. So just go to zoom and then 5. Yeah. It's called a z square.
Why is it called square?
Did that change your window?
Oh, yes. Yep. Just 3 for your r value. Yep. Oh, yours is still not working. I'll come over and I'll help you. I'll look at your window. Oh, are some of you in degrees? If you're in degrees, your window should be 0 to what?
360.
Yep, 360 because it's the whole circle. So make sure that if you are in degrees, you can still graph in degrees. It just has to be 0 to 360 instead of 0 to 2 pi. And a lot of times we are going to be using the radian values with this. So we're going to sketch a graph of the polar equation. And the first one we're given is theta equals pi over 3. So what this means is this graph is going to consist of all the points whose theta coordinate is pi over 3. Okay, so all of the graphs whose theta coordinates are pi over 3. And we're actually going to go straight from talking about this to graphing it before we do the rectangular coordinates because I think that's easier. Yeah, be more fun. It'll be easier. Yes, well, not anymore. Too much control. All right, so if you look at your graph of where pi over 3 is, let's get this. Okay, here's my line, pi over 3. All of these points on this line, pi over 3, are going to be included in our graph. Now, because this coordinate is kind of hard to see, I'm fine if you want to use other colors on your graphs. But this is going to be your graph. Okay, and yep, just like that. And I'm just going to draw, this is my rough sketch of it here because I want to talk about how this is all pi over 3. Because can you see how this part is labeled pi over 3, but this part is 4 pi over 3?
Yeah, it's still pi.
Yeah, it's still pi over 3. Do you guys remember what your R value would be? Yeah, so this is still pi over 3. This is just where your R value is less than 0. This is where your R value is positive. Okay, so just like we were talking about yesterday, yeah, this could be pi over 3 here, but it's still going to extend 180 degrees to account for those negative R values. Okay, and then if we want to describe this graph, probably the most obvious thing is what?
It's a circle.
What? Not a circle
This
anymore.
whole thing is a circle.
Yeah, but the one that
It's a circle of life. Right? No, this whole thing is a, yeah, it's a straight line, right? So it's a straight line that goes through pi over 3. Okay, so I just wrote it was a straight line on pi over 3. It goes through the origin, and it makes an angle of pi over 3 with the polar axis, which the polar axis is, yeah, just going to start at the 0. Yeah.
Can you explain the polar axis?
Yeah, the polar axis is just the same thing as the terminal side. So, like, this is your polar axis. It's going to be the line that's going directly towards the east. So it's always going to be starting at 0. Because we always are going to start there to find what our angle is. So, like, when we do this to here, the pi over 3, this is your polar axis. Okay. Okay, so now we're going to convert to rectangular coordinates, and then this takes just a little more effort. So we're going to go over this. All right, so when we're converting to rectangular coordinates, what we're trying to do is we're trying to write an equation in the Cartesian plane. And remember, the Cartesian or the rectangular plane deals with what kind of points? Yeah, good, okay, x and y. So when I say rectangular coordinates, I'm going to need an equation that has this. Okay, so Luke, if we're doing like a regular equation, thinking back maybe algebra 1, they're always going to start with what equals? Like every equation we do, it's always what? Yeah, it's always y equals, right? If we have an x equals, do you guys remember what kind of line that is?
Inverse.
Well, no. Well, when you switch x and y and solve, it's an inverse, but if it's just x equals a number.
Oh, it's a vertical.
Yeah, it's a vertical line, right? It's all the places where x would be that number. Do you guys remember that? And y's would be different? Yeah, so like if it was like x equals 2, that means when you graph it, right, you'd be at 1, 2, and the line would be straight through there. Okay? Now, you missed that. Okay, so now we have our theta. So our line is going to be a little bit different. So we have theta equals in this one. If you go to your graph and you look at your y equals, what has y equals been replaced with? R. So our R is similar to our y, which means our theta is going to be similar to x. Okay? So with this one, we're going to keep that in mind as we are going, but you are going to have some kind of equation that's going to relate y and x. So in order to do that, let's think about tangent. So in order to make our rectangular coordinates, we're going to use that the tangent of theta equals y over x.
This is from yesterday.
A little bit. Yeah.
Well, yeah, and so like we know tangent of theta equals y over x from yesterday, but also from chapter 5, starting to talk about the trig. Oh, yeah. Yep, exactly. So in yesterday's, that was for if you're going rectangular to polar. Yep. So for this specific one, we have theta equals pi over 3. And if you guys want to write this down in your rectangular coordinates space, that would be good. So if theta equals pi over 3, are you guys okay if I just substitute pi over 3 in for theta?
Yeah.
Okay, so let's do that. So I would just have the tangent of pi over 3. And then I can find what this equals. So I just substituted pi over 3 in for my theta value. So if I go to my unit circle, Sophie, do you remember what the tangent of pi over 3 is on the unit circle? Nope, you're thinking of sine, cosine. Think of tangent. Remember, it goes in order from least to greatest. Yeah, good. Square root of 3. Okay, so tangent of pi over 3 equals root 3. That's from the unit circle. So I wrote that on there. So when you're looking back, you would know where it comes from. And then, like I said earlier, we know tangent of theta is going to be y over x. So what we can do is replace the tangent of pi over 3 with y over x, because that's the definition of the tangent. We know that the tangent of any angle is going to be equivalent to y over x. Okay, so we needed the pi over 3 to know it was equivalent to root 3. And now we're going to solve this equation for y. Okay, and again, we're solving it for y because when you're in rectangular coordinates, what do you usually have? You're usually going to have y equals some equation. Okay? So for this one, if I wanted to get y by itself, Hannah R., what would I do?
Move the x over.
Okay, yep, how do I do it?
Multiply.
Yep, so we're going to multiply both sides by x.
That's your
Not yet. But then once you multiply by x and you simplify, that will be your equation. Okay, so you can write that two ways. So on this side, see how you're just going to have y? And then on this side, you can either write it as the square root of 3 times x, or y equals x times root 3. Okay, and if you do write it this way, just be careful that the x is not underneath the square root. Okay.
So it's not going to be actual, like, x normal y coordinates, it's going to be an equation?
Yes. Yep. So just like our theta equals, that is an equation, this will also be an equation. And we'll do that for the other one too. Okay, good. Other questions for me on that? Okay, so then those are going to be your rectangular coordinates. Now let's try them out. Let's see if it is equivalent. So if I go back to my calculator, change the mode back to function, and then graph this function and y equals, let's see if it looks similar to what we had before. Does that look similar to the same graph we have on the polar coordinates? Yeah, it is. Okay, it looks like it is approximately pi over 3 degrees. But what type of function is this?
Linear.
Yeah, linear, right? Do you guys know what your slope would be?
I don't know.
Root 3 over 1, right? Because that would be like technically in front of the x, and then your y-intercept would be 0, 0. Okay, all right.
So, are we drawing something on here?
Oh, this was for this.
Oh.
Yeah.
So
Yeah.
does the coordinate come out as?
Yeah, that was for your rectangular coordinate box for A, because remember I said we were going to graph it first because graphing was more simple for that one. For B, we are going to start by doing the rectangular coordinate.
Is that the coordinate then?
No, you're going to have your equation. So this is your equation. That's going to be your rectangular coordinate.
Like the whole thing?
Yeah. Okay, so this is what is going to be your rectangular coordinate. It is an equation because your equation is going to contain how many points? An infinite amount. So there's an infinite amount of coordinates that are going to match up with this line here. Okay, so let's do B. All right, so this is what we just did. These are our rectangular coordinates. All right, so for B, this is going to be very similar to what we did today, the first example, which was really the last example from yesterday. Okay, so I want you to use that to help you with part B. So I'm going to give you some time to do that.
That's like the smallest circle.
I know.
Okay, so looking back on what we did yesterday, or technically today, what was our first step?
And multiply both sides.
Okay, yeah, so you're going to multiply both sides by what? You're going to multiply both sides by r. How many of you were able to do that already? Multiply both sides by r. Okay, so again, look on that last sheet. That is our very first step, is to multiply both of your sides by r. Okay, so then if I multiply both sides by r, do you guys know why I want to multiply by r and not square it? Not square both sides?
Sometimes squaring introduced problems like plus or minus.
Yeah, and it wouldn't be the same value. Yeah, it is going to change the value. Exactly. You can't do that. So now that I get here, I have r squared. And then can you guys look at your equations from yesterday and see what you plug in for r squared? Samantha, well, what are we going to plug in for r squared? That we are going to do that as well. This one for r squared, yes, will be the x squared plus y squared. And then Samantha, tell me the other thing you were talking about. Good. So can you guys see this from yesterday?
Yeah, I see it.
Wait, what? Oh, shit.
Okay, so remember from yesterday that r times the cosine of theta is going to equal x, so I'm going to substitute. What are we probably going to do now?
Move the x.
Yep, and complete the square, yes. Complete the square, yes.
Then we just get the square of the x is not the y.
Exactly. So you're just going to complete the square in the x, not the y, because the y doesn't have a b value. So then technically, if you were to complete that square, it'd be like you were adding 0.
So can we just leave the y squared?
Yep, so we're just going to leave the y squared here. And remember, this should be a circular equation. Okay, so Nick, can you tell me what I'm going to put in the first blank space here? Do you remember the equation? Okay, so b over 2 squared, yep. So our b value for this is? What's in front of it? Yep, so b, yeah, 1/2 squared. And 1/2 squared is? Yep, good. Okay, so then that's going to go on this side. Yep, and then Luke B, what do I do now? Good, so when I factor, this whole thing is going to be x plus 1/2 squared. Do you guys remember why I write that as 1/2?
That's what it's going to be when you take it out.
Right, so then you don't even have to think about the factoring part. Yes, you are. Please note that. Okay, and then let's pick out what the center of the circle is going to be. Not 1/2.
1/4.
No. Negative 1/2. Yeah, so the center is always the opposite.
Do we need to like identify the center? Is that part of
Well, it's going to be helpful when you graph, and I'm going to show you where the center is on there so you can see how it is going to be the center of the circle. And now we are going to graph our coordinates, some of you for the first time ever. So exciting. So I'm going to show you first how to do this without your calculator, but we are going to end up using calculators. So then I'm going to show you how to do it with a calculator. Okay, so how to finish it with one, but how we can get points without it. So remember how before I showed you the X and the Y, and we talked about how those are similar to the rectangular coordinates? This is going to be similar, so we're going to do a table, except our table is going to be theta and r. So instead of X and Y, we have theta and r. Now that's kind of a little bit backwards from like the X goes first and then the Y, but our equation is r equals negative cosine of theta. So our independent variable is what? Our independent variable is the theta. The independent variable is the one that can stand by itself. The other one depends on that variable. So like see how whatever you plug in for theta, that's going to affect what your r value is? Okay, so let's pick some easy values. So like 0, we're actually going to do ones that are in the first quadrant. We'll do 0, pi over 6, pi over 4, pi over 3, and pi over 2.
Is this for graphing?
Yep, this is for our graph.
So was that x plus 1/2 squared? That was the rectangular coordinates?
Yep, so those were the rectangular coordinates. So now we're going to graph.
Wait, what's the rectangular
Are
coordinate?
we going to have calculators like figures and this kind of stuff?
Yes, you will. What did you ask me, Hannah?
What's the rectangular coordinate?
The rectangular coordinate is just the equivalent, but in the Cartesian plane. So like you have the polar
Wait, what
plane
is this?
and then the
Are
Cartesian
you saying
plane.
that this is the rectangular coordinate?
Yes. So I'm saying if you were to graph this in a regular coordinate plane, this would be the equation that you'd use. So these two equations are equivalent. This is it in polar. This is it in Cartesian or rectangular. Okay, so we can find all those values where? Yeah, on the unit circle.
Stuff's coming right over.
So you can use the unit circle. You might want that out if you don't know it. Did you guys already fill in? Yes. Okay, so when you're finding this, all you're doing is plugging in your theta value for theta. So it's negative cosine, in this case of 0. The cosine at 0 is what?
1.
Okay, so this will be negative 1. Okay, at pi over 6, the cosine at pi over 6 is what? Yep, so this is going to be good. Okay, so can you fill the rest of those in for me? So pi over 4 would be good. Pi over 3 and pi over 2. Okay, so now when we're graphing this, the exact values here that are decimals are not going to be helpful unless they are in decimal form. So we are going to write these in decimal form, and then we're going to end up estimating.
Do you have these memorized?
No.
She's probably done this
She has
3
like
times
so
already.
many formulas.
Yeah. No. Okay, so once you have these down, I'm going to show you how we're going to graph it. And again, if you guys want to graph this in color, you can. I'm going to graph mine in color so that you can see it easier. And then I just ask that you watch me for at least the first 2, and then you can start doing it as well. Okay? All right, is it okay if I go to the graph then? Okay, so my first point is 0, negative 1. So here is my 0 line. Okay, right here. So you probably want to look up here so you can see this part. So at 0, if I were to go 0, positive 1, I would be here towards the 0. because it's negative 1, instead of going towards 0, where am I going? I'm going away from 0. So my first point is going to be right here. This is 0, negative 1. Okay, right there in my graph. Oops. Okay, now the next point I have is pi over 6, and that's going to be about negative 0.87. So if I go to pi over 6, again, instead of going towards it, because it's negative, I'm going back. Now, if you're looking at these and you're having a hard time, because I feel like this one looks a little bent, finding which one is the one straight across or 180 degrees, what's a little tip you can use?
Look at the reference.
Yep, it has the same denominator. So if 6 is on the bottom here, this is what it's going to be. So again, I'm going to have to estimate about negative 0.87, which is right here. And you guys can start doing this. Okay, and then my next one, pi over 4, is at negative 0.71, so I'm going to estimate that. So it's a little bit more in. And then at pi over 3, I know, this one's smaller. Some of them are going to get bigger, so they're not always going to be this tiny. Give it a chance. Okay, and then the last one, pi over 2, 0, right here. And if I just connect all those points that we just plotted, what do you think this is making?
Half circle.
It is.
Pi over 2 is 0, so it's just at the origin.
Yes. Yep, it's just at the pole there. What's that?
The reflection where you see
Yep, it is. It is. And I'm going to show you how you can find all of the points on your graphing calculator. So we're going to go there now. So I'm going to, again, make sure my mode is in polar. It's like pole and mode. Oh.
Please excuse the interruption. At this time, please release the boys and girls bowling team.
Bye.
So on like a test, you want us
Yes.
to do like halfway like this, where you use the table, and like halfway in the graph, or just on the graph?
I'll tell you that in a second. That's a good question. Okay, so we're gonna graph this. So negative. Stay with me, please.
So small.
And then the video will be online. And your homework is to finish the last 3 problems from yesterday. Okay. Okay, so negative cosine of theta is what we have. And then Michaela asks, like, if we're on a test, is this how we're going to do it? If you're on a test, I'm still going to have you make a table. What I'll have you do is just label 5 points on that table, and you'll label them A, B, C, D, E. And then on your graph, you'll label them A, B, C, D, E. So you'll have all of the points, but then you'll pick 5 of them to label. And we'll practice that as well. Okay, so now I have my equation here. Look at this table set. So we're going to go to second table set, and then it says table start. We're going to start at 0. And then this is asking me what I want to go by. Let's look at my polar grid. What does my polar grid go by?
Pi over 12.
Pi over 12. See how this is the first one here? Pi over 12. So what we want to go by is pi over 12. So I'm just going to do pi divided by 12. Now when we get the table, this is going to generate a point for every single line. So if I go to my table, we've already done the first one, 0, negative 1. We didn't do pi over 12 because that wasn't an exact value on the unit circle. But then look, here's pi over 6, pi over 4, pi over 3. The next one's 5 pi over 12. And then we're back here. We should recognize 1.57 is what?
Pi over 2.
Yeah, it's pi over 2. Okay, so I'm just going to scroll up a little bit. So that's pi over 2. So then if I wanted to graph the rest of these, after pi over 2, that's going to be 0.25. So I'm just going to go to my next line, which is here at 7 pi over 12, and I'm going to estimate that at 0.25. My next one is 2 pi over 3, and that one looks like it's at 1/2. And then my next one's at 0.7, then 0.8, and then 0.9. And then when you connect it, it will make your circle.
Are we supposed to know the decimals?
That, like what value, like what rating values they are?
Yeah.
No. So that's why you're going to use this as the order that it goes in. So like at 1.57, you know this is pi over 2, right?
Yeah.
Okay, so from there, the next one, the 1.83, is just going to be the next one on your grid because we went by pi over 12.
Okay.
And then so the next one is 2.09. Can you guys see that?
So it's okay for estimating about where it is?
Yes, and you were asking about these values, right, Michaela, like these?
Yeah.
Yeah, okay. Okay, and then our circle, if we look in the center, I put a little dot in there. And that's going to be our center here. Yeah, -1/2, 0.
So, because it's on the 0 line and then you're going to the left.
Yeah.
That makes sense.
Actually, would you mind shutting that for me? Thank you. Right, so -1/2, 0 is going to be the center, and your radius is going to be 1/2. All of these are going to be 1/2 from your center. So it says, describe this graph. So the graph is just going to be a circle with the center -1/2, 0. Let's see how I have the circle equation on the board. So H and K are going to be the center. See how there's a negative in front of both of them? So that means the opposite. So see how our equation says x plus 1/2? So when we take it out, we do the opposite. And then so it's y squared equals added to it, so that'll be the 0 part. Okay, and then I just put this here as a reminder, so you can set your table on your calculator to go by pi over 12. That will show you every point on every single line. Now, you don't have to graph every single point on every single line every single time. Okay, as we go through this, we'll pick out certain points that you need on there. But if you like to make sure that you have it right, you can always do it by going by the pi over 12. Okay, let's look at the next page. All right, so in general, the graphs of the equations of the form R equals 2a times sine of theta and R equals 2a times cosine of theta are circles that have a radius of the absolute value of a. Oh, sorry, you guys can see all of that. Oh, we'll talk about that. Yeah. Okay, so centered at the points with polar coordinates. A pi over 2 and a 0. Okay, and then this is from page 549 in your textbook. Okay, and you can see figure 4 for the relation. Okay, it is again another circle. So this is also similar to the one that we just did, right? Where we had A0 and we had our -1/2, 0. Okay, and then specifically we're going to look at graphs that are called Lamersons. They are French. Don't I sound like Lumiere from Beauty and the Beast?
Yeah.
Lamersons.
Is that an S?
That? Yeah, so,
little squiggle, right?
yes, it is. And some of you French people might have to help me. That's what it is. It's like a little C with a squiggle on it.
Why? Why is there a squiggle?
I don't know. They like to make it fancy. Right? If it has the equation of one of these forms, it is going to be a limosome, and there are some special ones as well. So you'll have some value A, and then that'll be plus or minus B sine of theta, or you could also have the cosine. There is a special limosome that's called a cardioid, and if you think of the root word of cardioid, what do you think of? Yeah, the cardio, which has to do with the heart, right? So it's going to be slightly heart-shaped. And the equation, you can either think of it the same as above, where the A and the B are equal, but you can also write the equation in this form, because technically the A and the B are going to be the same. And this is how the book is going to write the equation for you. So these are just general forms of the equations. As we start to work with them, then you'll be able to recognize them better. So, for example 2, when we're sketching this graph of R, that's going to equal 1 plus the sine of theta. And you can see we have 2 steps. So in the first step, you're going to sketch in rectangular coordinates, and we're going to use that as a table of values, and then we're going to plot that on the polar grid. So we're going to do that step 1 together. Right? So what we're going to do is graph y equals 1 plus the sine of theta. So we have to go back to chapter 5. So saved by the bell. Okay, so your homework is just to do the last 3 problems.